Alright, in this video we're going to look at the remainder and factor theorem. This is going to help us factor polynomials. So first we need to look at the remainder theorem, and it's what we get when we divide some polynomial by ax minus b. So if we write it in our long division form, we'd have p of x, the polynomial, under the division sign, ax minus b on the outside, and we'd get a result of q of x with a remainder of r. For example, if we divided 6x cubed minus 11x squared minus 22x plus 34 by 2x minus 5, we'd get 3x squared plus 2x minus 6 with a remainder of 4. You can work that out yourself. Alright, so we're going to write the general form of a division statement then for this. So we've got the divisor, which is ax minus b, the dividend, which is the polynomial p of x, the quotient, which is q of x, and the remainder r. When we look at this one, if we want to write the division statement, it's going to be 2x minus 5 times this quadratic plus the remainder equals this. So we've seen this before. So I'm just going to write it in general here. So we've got p of x equals q of x times ax minus b plus the remainder. So that's the generalized division statement for this type of division. Now, if I want to find out what the remainder is, well, let's try something here. If we look at this part here, this whole part is going to be 0 if I put in x equal to b over a, because this part will be 0, and 0 times anything is 0, and we're left with the remainder. So this is kind of a neat trick to look at this generally. If I let x equal to b over a, this part goes to 0. So p of b over a equals q of b over a. And then I'm going to put b over a in for x. Plus r. So at this point, these a's cancel out, and we've got b minus b, which equals q of b over a times b minus b plus r, which equals q of b over a times 0. Anything times 0 is 0, so we're just left with r. So now we get p of b over a equal to r. This is an important result. So this factor, if we take the value that makes that factor 0, so the root, or the 0 of that factor, and we plug it into the polynomial, it will get us the remainder. Okay, so that, in fact, is the remainder theorem. And we can test it here. We can test it in this one here. We can look at this, call that p of x. Okay, so as a test, if we try the value that makes that 0, p of 5 over 2, we plug that in. This is a long calculation. You can check it on your calculator. Okay, so if you plug that all into your calculator, you'll get a result of 4, which is the remainder. Okay, so that's a quick way to get the remainder and find out whether this is a factor or not. So this is leading us to the factor theorem. So first we're going to state the remainder theorem. So the remainder theorem is when p of x is divided by ax minus b, the remainder is just p of b over a. Okay. And this gives us the next theorem, which is the useful one, which is so this is the remainder theorem, and then we have the factor theorem. Okay. So the factor theorem happens, well, when the remainder is 0. If we look at this statement here, p of x equals q of x times ax minus b, if we've got a remainder of 0, then we've got p of x factored into two pieces, q of x times ax minus b. Okay. So p of x equals q of x times ax minus b, then r equals 0. Okay. So here's the statement. When p of x is divided by ax minus b and p of b over a equals 0, then ax minus b is a factor of p of x. So that is p of x equals q of x times ax minus b. And we factored it partly. And that's the factor theorem. In the next video, we're going to look at how to factor polynomials using this.